The scales that we assign for the measurement of temperature are basically fixed on the basis of 2 points, that is freezing point and boiling point. Freezing point of water, that is 0 degrees Celsius if you consider the scale of Celsius. Similarly, boiling point of water, that is 100 degrees Celsius. These 2 points were considered at fixed point. One is called lower fixed point, that is freezing point of water, and the other is called upper fixed point, that is boiling point of water. Two scales were designed, Celsius and Fahrenheit. In Celsius scale, it's degree C. Parallel scale was, that is Fahrenheit. Here freezing point, that is lower fixed point, you could say, lower fixed point. This was taken as 0 degrees Celsius. On Fahrenheit scale, this point was taken as 32 degree Fahrenheit. You see, absolute scales were modified for these scales. For Celsius, absolute scale was Kelvin, and for Fahrenheit, the absolute scale was Rankine. Rankine. There was one more scale that has become obsolete and that is not much concern. So we are not considering that. That is Reaumur scale. So we are talking about only these two scales, and by parallel, the Kelvin and Rankine scale also. When we add 273.15, we get Kelvin. Remember, if you add 273.15 in Celsius reading, you are going to get Kelvin scale reading. And here, if you add 459.67 in Fahrenheit reading, you'll get the reading on Rankine scale. So two things are clear. Kelvin is the absolute scale of Celsius and Rankine is the absolute scale of Fahrenheit. Celsius and Fahrenheit are also connected together. If you consider the difference between upper fixed point, what is this upper fixed point? Boiling point of water, that is 100 degrees Celsius. And here this is going to be 212 degree Fahrenheit. This is the boiling point of water on Fahrenheit scale. The difference between lower fixed point and upper fixed point is 100 division on Celsius scale. On Kelvin scale also, remember that number of division will be similar on both the scales. This is difference of 100 division on Celsius and here on Kelvin also, because it's going to be 373.15, the boiling point of water on Kelvin scale. So difference of 100 division on both the scales. Similarly, if you consider the difference between Fahrenheit readings of freezing point and boiling point of water, this is going to be 180 division. Difference of 180 division is that between the two extreme points on Fahrenheit scale and on Rankine scale. But here we have to be aware of one thing. Though Kelvin is considered as SI unit for temperature, but still it's not so popular in USA and some other countries also. In thermodynamics, still Fahrenheit unit is popular and that is used by certain scientists. A group of countries also prefer, but for there we have not to be so particular. SI unit is still Kelvin. With Kelvin, you have to note down one very important thing, that externally with Kelvin, we don't use the term degree. For other units like degree Celsius, degree Fahrenheit, degree Rankine, we'll use degree with all the units of temperature, but it's exceptional for Kelvin. We don't use degree with Kelvin. It's simply read as Kelvin. There is one specific reason behind it, because in mid-era it was considered that temperature will be mentioned by degree Celsius and temperature difference would be mentioned by Celsius degree, and that created in a kind of ambiguity, a kind of doubt, confusion. That's why it was finally decided by international group of physicists that with Kelvin we are not going to use degree before or after.